In section 4.4, we're keeping the focus on triangle proofs, except we're adding in one little piece that we haven't seen before, and that's should be corresponding parts of congruent triangles. So with the theorems we've seen so far, side, 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 angle, side, angle, angle, side, we know that we could use three congruent parts of two triangles to show that two triangles match. And once we know that those two triangles are congruent, this is our extra step. We can make conclusions about their corresponding parts because, as by definition again, corresponding parts of congruent triangles are always congruent. We're going to see that a few times in this paragraph. If you know triangles are congruent, then you know that every pair of their corresponding parts are congruent, and that kind of comes from the first section. Everything from one triangle could match the other. So we're going to abbreviate that in our proofs as Cpctc, and that's corresponding parts of congruent triangles are congruent. So we care about that corresponding parts of congruent triangles, going to make them congruent. In our proofs, we can shorten that whole thing up as Cpctc, but again, going to want to make sure we know where that comes from if I ask you a question on the abbreviation. So what that means again is that all 6 parts, because we have 3 angles and 3 sides, they're going to be congruent to all 6 parts of another triangle if the two are congruent. So let's look at that in practice with our first proof. First proof, we actually have 2 congruencies to start with, which is a good place to start. We know that if we're trying to prove, notice our proof statement is different. What we've seen so far in this chapter is that we want to prove 2 triangles are congruent. Here we want to prove that side KB is congruent to side AC. So it looks like we're trying to prove that the left and right sides are congruent. So if I start with my given, it tells us a pair of congruencies. We have KBC, that angle in the bottom left corner, is congruent to the angle in the top right, ACB. We also have another pair of angles marked congruent, and that's K and A. So I want to make sure we list the given first, and then for our next step, again we see the side that's shared down the middle. It's a pretty common start to our triangle questions. We can use that shared side as a reflexive congruency. And now it looks like I already have 3 pieces from each triangle. I have 2 angles and a side, 2 angles and a side. So I can take another step and prove that those 2 triangles are congruent by using what we saw in our last section. That's angle, angle, side. Again, the side doesn't lie in between, so 2 angles with the non-included side, 2 angles in the same non-included side. That does make the 2 triangles congruent. So really the only thing we're adding in this section is one more step. We don't want to stop by saying the 2 triangles are congruent. We want to stop by saying some pieces from those triangles are congruent instead. So after we've shown those 2 triangles are congruent, and again that was by angle, angle, side, we're just going to add one more step to reach our proof. So KB and AC, those segments to the left and to the right, they're congruent because they are corresponding parts of congruent triangles. So that's our Cpctc. Corresponding parts of congruent triangles are congruent. You do want to make sure that they are corresponding parts, and in this case they are because KB is in between angle 1 and angle 2, and AC in between those 2 same congruencies, so first angle and second angle. So those corresponding parts should be congruent. So trying that again on another proof. And this one again, we start with a lot of information. BA and DA are congruent. CA and EA are congruent, so we've labeled those 2 pairs of sides congruent. And again, we don't want to prove the triangles are congruent. We want to take that a step further and say that 2 corresponding parts, angle C and angle E, should be showing that those are congruent instead. So still start with a given, and just notice the shape, kind of like the last one, is a common figure. This question is a common figure as well. I have this bow tie shape, meaning that I have 2 vertical angles in the middle. So you want to be careful not to say angle A. It should be angle CAB is congruent to angle EAD, naming that with 3 letters to be specific. And again, we know that those are congruent because those are vertical. And after I have those parts, looks like I have 3 pieces on each triangle, so that should be enough. I have 2 sides and the angle that's included, 2 angles and the angle that's included. So I should have side, angle, side to prove that the left and right triangles are congruent. But again, if I want to take one more step to show corresponding parts, I'm just going to take one more step after I've proved the triangles are congruent. I can say that C matches E, so those 2 are congruent because, again, Cpctc, corresponding parts of congruent triangles are congruent. So our new step is really just one thing we're going to add in after we prove triangles, is just looking at not the triangles but their parts. That's just one extra step. So same idea on this, not quite a word problem, but we have a picture for it. A couple of different parts of the given. Angle TRS and angle TRL are right angles, which is kind of hard to see on mine, but should be towards the bottom of your 2 triangles. And angle RTS and RTL are congruent. So we're also given congruent angles at the top, which is again a little bit hard to see. So we want to use this to prove that RS is congruent to RL. So it looks like in this figure, the distance from the bottom of the tower to your boat is the same as the distance from the bottom of the tower to the tree. So notice again that we're not asked to prove that triangles are congruent, but proving that the left and right triangles are the same is going to be helpful to show that those corresponding parts, the bottom of one triangle and the bottom of the other triangle, those should both be matching as well. So if we start this, I want to start by listing the given exactly. Again, don't want to skip any parts of that given. And notice that we're told one pair of congruencies from the given is that RTS and RTL are congruent. The other statement isn't quite a congruency, but we should be able to use it to come up with a second congruency. So what I said for step 2, and again, step 2 and step 3, you can kind of flip around here if you'd like. But since I know that TRS and TRL, those angles are both right angles, I can say they're both congruent to each other. So step 2, angle TRS congruent to angle TRL, because every right angle should always be congruent. And this next step that I'm adding in could have been your step 2. But we're just saying that they share a side. You want to look for that as a common start. Remember to your proofs. TR is the same in both triangles, to the left and to the right. So I can say that since TR is shared by both triangles down through the middle, again, that's always going to be a reflexive side that's shared. So TR congruent to itself by reflexive property. And that should give us enough statements to say that the two triangles are congruent from the left and the right. Again, if I look through my proof, I have 1, 2, 3 congruent pairs, and 3 congruent pairs is what I need. In this case, we're using angle side angle, since we're given the angles at the top, the angles at the bottom, and the side that we found was in between those two angles. So whenever we think the sides in between included, that should be angle side angle, not angle angle side. So angle side angle we're using to prove the two triangles are congruent, and then again to reach our last step, RS and RL are congruent, just with one additional step, because I know that corresponding parts of my congruent triangles are congruent. So you want to be careful. You can never use this reasoning unless you've proven the triangles are congruent. So our first goal should always be to show that the two triangles are the same, and then I can just take one step at the end and show that their pieces are the same. So we don't want to prove RS and RL are congruent first, show the triangles are congruent, and then take that last step. So last proof, let's see if we can use this the same way. We start with, looks like one congruency and another part of the given that should help us get a congruency. So AB and AC are marked congruent. That was the, looks like, top and bottom sides of that bigger triangle. We're also told that M is a midpoint, which should help us with another congruency. But again, notice our proof. We don't want to prove two triangles are congruent, but if I can prove that the top and bottom triangles are congruent, that's going to help me with their corresponding parts. So first step is to list out the given. Second step, the given tells us one congruency. It tells us about a midpoint, but I have to use that to get another congruency. So if I know that M is a midpoint of BC, that should tell me that BM and CM are the same length, because again, that's why we're using that midpoint, to break those two parts up evenly. So I can say that as a congruency. BM and CM are congruent, again, because a midpoint creates two congruent segments. If you put something like definition of a midpoint, you'd see that in the book too, but that's pretty much why we're using it. It's a midpoint, and that's going to make those two congruent segments, so two segments of the same length. And notice the shape of this figure again. So if I have two congruent parts so far, one pair of sides and two pair of sides, we can use this third side down through the middle. Remember, that's still your reflexive piece. So AM, that side is being used in both triangles for the top and the bottom. So I can say it's congruent to itself. Remember, that's always reflexive. So in this case, we didn't have to show any sides at all. If I have 1, 2, 3 pairs of matching sides, that's just proof for our two triangles are congruent by side, side, side. And one last step is to show, again, not that the triangles are congruent, but that their parts are congruent by Cpctc. So whenever we use this new step, always want to make sure that we prove the triangles first and take this step after to finish with. And again, that's because we didn't want to prove the triangles. We wanted to take that one step further and prove their parts. So make sure we have these notes down, and we'll practice that together in class.